All right, programming 12. So now that you've had a chance to practice with this and you have, functionified your house or decomposed your house into functions as opposed to the bottom-up programming, now we're going to see even more value to this stuff about translate. So translate, in addition to moving things around, there's other transformations which you can do. For example, you can scale, you can rotate, and there's more besides. So I want to show you a couple of those things just so you can get like a sense of the possibilities that are here. So the first one I want to show you is scale. Scale is super nice because then you can shrink things down. Scale literally means like change the scale of something. So there's a scale function. You have to do it after the translate. Well, I guess I shouldn't say you have to, but for most logical purposes you would. I suppose there might be a reason why you want to scale and then translate, but for our purposes, if we want to be able to shrink the head down, we want to use the scale function. So check it out. If I just put in 0.5, this is like means 50% scale down. I could put in like, 1. And like everything inside of here, all the coordinates that we're using for the skin, hair, eyes, will be 1/10 of the previous numbers. It just automatically adjusts all those numbers. It's really quite powerful. So I'll put 0.5 and we'll just see like I had these three faces sort of layered on top of each other, and now they're smaller. And I can kind of move them around a bit. The outside coordinates out here are still in the regular coordinate space. It's just within the face function itself, after this push matrix happens, that the coordinates are shrunk down and all this stroke weights and everything are shrunk down as well. So like if I made this like 100, 100, and I don't even know, 400, 100, and then 400, oh gosh, 400, wait, this is 400, so 100, 400, I don't even know if I'm making sense here, and then 400, 400, let's see. If I did it like that, I could now get, I didn't quite nail it, I can get my four faces out there on the screen now. And if I want to, I could make this a parameter. The verb of that is I could parameterize this value. So in other words, I could send like a value, and then I could receive it here, I guess that would be a float. Maybe I can't use the word scale, that's a function name, so I'll just use s, and I could apply it here. So like I could have some that are 0.1 and some that are 0.8 and some that are 0.4 and stuff. So I could be able to control the face size from here. So this will be x, y, and scale factor. So if I run that, I get different size heads now. So that can be a pretty useful feature, especially if I wanted to have many different faces. Maybe this is going to be a video game and the faces are coming at you and they're getting larger or something. That sounds kind of creepy, actually. But I'll just put them all as 0.5 for now, and then we can see they fit nicely onto the screen. If I put just 1, then I'll get the regular size face that originally I had drawn. So that's how that works. So that's scale. We also have rotate, and I'm actually blanking on whether it matters if we rotate or scale first. I guess we'll just try it. So you can rotate, which means basically spin. So I'll rotate. Well, unfortunately, it's in radians. I don't know if unfortunate is the right word. Radians are an amazing way to measure angles. You might not have encountered them in math yet if you haven't taken Math 11, or if you're just starting Math 11. You might not have seen radians. Basically, radians measure an angle based on tracing a path around the circumference of a circle. And if you recall, the circumference of a circle is 2 pi r. So a 360 degrees is 2 pi r. But r, we assume, is 1. We assume the circle has a radius of 1. So it's just 2 pi, because 1 times 2 pi is 2 pi. So that's 360 is 2 pi, and then we can sort of work on what the conversions are by setting up an equation. So like 90 degrees, for example, is pi over 4, and so on. And why pi? Well, pi is actually a great number for working with angles, and oftentimes you might be like, oh, I don't want to calculate pi, I just want 360 or 90. True, but pi often cancels out in these calculations, and Why 360? That's just kind of a number people chose because it's easy to work with. It has lots of factors and stuff, but it's not really based on a universal concept. It was just a number that people chose. So that's why we use it. Anyways, I can actually type in, say, pi over 4, and that will rotate the heads 90 degrees. Oh. Am I wrong? Oh, that's 45 degrees. Pi over 2. Embarrassing, that's going to be recorded on YouTube. So now I can rotate. Pi over 4 is 45. So I can kind of rotate these heads now. You'll notice that they're rotating around this corner. And, that might be something to think about if you do want to, in the future, have your heads, rotating. If you don't want them to swing around that corner, then that shouldn't be your 0, 0. Where you translate to, the rotations happen around that point. So if that's like, not really what you wanted, then yeah, sorry, that's this face will be a little bit unfortunate. But in the future, if you're making a function wanting to be able to apply a rotation, just plan it out from the point that you want to rotate around. Maybe it's the center, whatever. It doesn't really matter. Great. Hey, one last thing I just wanted to mention. I'll get rid of the rotate for now. Also, we can, let's see, we can also add in extra eyes. It's really easy. We can just add an eye. So instead of it being, we can say 200, 100, we can throw an extra eye in there. And that's all I got to do is just say, and then all my faces will have 3 eyes, which is creepy and awesome. And, all I have to do is type in eye. This is the center eye now. So awesome, right? So these functions are just so useful. We're able, once we kind of break it down into functions, we're able to do so much more with our work that we've done. It's not locked into these coordinates. It's movable. It's expandable. It's reusable. I think I said reusable. I reused reusable twice. I just love it so much. I can't stop talking about it. So I'm going to stop, let you get back to work. That's everything I wanted to say about functions for now, but in the future we'll come back and talk about, hey, what would it look like if a function returned a value like f of x or g of x? But we'll move on to a new topic. For the next videos, we'll talk about, I guess we're going to do some interaction, clicking on things and pressing keys and stuff like that. So look forward to seeing that. Thanks, everybody.